really weird name for what we're going to look at there, but it is. Well, I don't think it's a racist comment. I think it's whatever they've called it. So this first question, we're dealing with log base 2x plus 3 minus log base 2x equals 5. Now, what we looked up at this point is we've talked about, subtraction becomes division and just doing that. But the problem with this is you'll notice on the right-hand side that this is not in log base 2, right? So I can't eliminate the logs yet, okay? So I have to set this up so that I get everything in the log base 2 first, okay? So this is going to take a few steps. If you follow me kind of step by step, it'll make sense, I promise. So the first thing we're going to do is we're going to take our first term over here on the far left-hand side, and we're going to, for all intents and purposes, do what we would have to solve it just by itself, which means we're going to say log x plus 3, over log 2. What that does is that gets everything there in log base 10, okay? And then we're going to subtract log x over log 2. Okay, now what you see at this point is I have actually created two fractions that have the same denominator, right? So I can rewrite that as log x plus 3 minus log x all over log 2. Okay, and that's set equal to 5. Now, just dealing with how we would normally deal with logs, what am I going to end up doing with that log 2 or log base 10 2 in the denominator position? Multiply it to both sides. So, and I know that, so we're going to do this. So I've got 5 log 2, right, and I can cancel that out there. Okay? So what I'm going to do at this point, just because I feel like I'm going to end up creating a cluttered mess here, is we're going to move over to another page. All right, so what did I have there? I had log what? Log x plus 3 minus log what? X equals 5 log 2, correct? Okay. Do all of these steps so far make sense to you? Okay, great. All right, so what we're going to do now is we're going to move that 5 up, and we're going to make it the exponent to log base 10 2. Okay, so it's going to become 5. Now what I can do is, well, we're going to see, and I'll just kind of do every little step. Sometimes we'll do several of these things together. Okay, so now everything is in the same log base. Everything is in base 10. Does that make sense? All right, so we can start to, because everything is in the same log base, I can get rid of those logs. All right, I can write this up as x plus 3 divided by x equals 2 to the 5th. But rather than write 2 to the 5th, let's go ahead and figure out what 2 to the 5th is. 32. Okay. Okay, I'm going to multiply by x on both sides. So I get x plus 3 equals 32x. Okay. We can subtract an x over here. So we're going to get 3 equals what? 31x. All right, divide by 31. And so x equals 3 over 31. All right, that looks like a lot of steps, but what I essentially did is I did every single step as a whole new step, where usually we would end up doing maybe a couple of those steps together. Okay, but does all of that make sense up to that point? Okay. All right. But they look super complicated, right? All right, so we have somewhat of the same situation, actually, pretty close to the same situation. The only thing that you'll notice differently on number 2 is instead of minus, it's plus, okay? But our first step is still going to be the same, right? Because it's set equal to 1, which is not in log base 12. All right, so we're going to have to first get everything into the same log base. So we're going to show my first term and my second term as division. All right, so log x minus 3 over log 12 plus log x minus 7 over log 12 equals 1. We're going to multiply by log 12 on the other side, right? So I should wind up with, you know, I'm kind of verbalizing this, but if we understand the process, then I can kind of get to a certain point here where I am seeing that I'm going to do x minus 3 times x minus 7 is going to be equal to, well, I'm getting, let's see, times log 12. So that 1 would become the exponent to 12, but it's just going to end up being what? 12. So I'm winding up with x minus 3 times x minus 7 equals 12. Now, I see pretty much everything at that point. Is there anybody in here that wants me to go back and do each of the individual steps that we did in question number 1? No? Are you sure? Okay. So just looking at this, what we have here, what would we do with this? We would FOIL, okay? So we're going to get, let's see, x squared, we're going to get minus 7x minus 3x, which is going to end up being negative 10x, right? Negative 10x plus, what, 21 equals 12. We need to subtract 12 because we want to get it into our quadratic equation. What's 21 minus 12? Let's see, plus 9 equals 0. So if we break this down, we'll see if we can. We're going to get x and x. We should get minus, looks like probably 9 and 1, right? 9 and 1. All right, let me flip on over here. Okay, so x equals 9 or 1. At this point, it can't be either. It can't be both of them. So you have to plug it back in and see what's going to work. And in our answer, 9 is what works. Because this is what I want you to understand. If I plug in 1, then I'm getting 1 minus 3. I'm going to get a negative log number there, and I can't. Okay? I'd get 1 minus 7. That's going to give me a negative log number there. But if I plug in 9, 9 minus 3 is 6. 9 minus 7 is 2. That gives me positive numbers, right? So if I ever get a question like this where I have 2 solutions, then I need to be able to pick one of them and understand why one of them is correct, because I can't have a negative log. Okay? So do we understand how we get 9 for that? Okay, like I said, I skipped a lot, so if we need to go back and show the kind of the expanded version of this, I'll do that. All right. All right, number 3. Again, most of these are going to come out as the same step. The only thing that 3 has different than, let's say, number 1 is that 1/2 off the beginning of it. All right, what would I want to do with that 1/2? Move it to the exponent of the 16. All right, and then probably what I'm going to do is I'm going to go ahead and reduce that. So 16 to the 1/2 would be the same thing as the square root of 16, right? So I can even go ahead and simplify that as log base 4, right? Minus log base 4 x plus 5 equals 1. Now, my tendency in this is to see log base 4 and say, well, I already know that equals 1, right? But if I do that, I'm still left with the problem that I've got a log base 4x plus 5, and I need first to get everything into the same base, all right? Because you can go and say, hey, I know what log base 4 is, and not be any closer to the answer, okay? So what we're going to do here is log 4 over log 4 minus log x plus 5 over log 4 equals 1, okay? So my numerator is log 4 minus log x plus 5. We can go ahead and move our log 4 over there, but because my answer was 1, what is my, I'm going to end up with, let's see, should just be log 4, right? Because 1 becomes the exponent, but it's not going to change the value. So I can rewrite this as 4 divided by x plus 5 equals 4. Okay? We're going to multiply by x plus 5. we're going to get 4 equals 4x plus 20. Okay, let's see, we can subtract 20 to the other side. We're going to get negative 16 equals 4x. All right, what's negative 16 divided by 4? X equals negative 4. Okay? And you'll notice that that doesn't necessarily cause a problem for us, because if we plug in negative 4 in this x plus 5 section up here, negative 4 plus 5 is 1. Okay, so I'm still wind up with a positive log there. Okay? All right, let's see. I'm going to let you guys work on number 4 here for a second. You guys should have had enough practice with this to work that out. I'm going to hit pause on the recording. I want to see your answers for this. I want to make sure that you guys can actually do these. Okay, so, just kind of verbalize some things out here. We know we're going to get log x plus 8 over log 4 minus log x over log 4, right? So we know we're going to multiply log 4 over on the other side, right, which is going to end up giving me a 4 squared, right, which is going to be 16, correct? So I need that 16 on the right-hand side. What I'm going to get over on the left-hand side is x plus 8 divided by x. So if I can go ahead and kind of fast forward to that, I'm going to get x plus 8 divided by x equals 16. So we're going to multiply by that. We're going to get x plus 8 equals 16x, right? We're going to subtract x. Right, we're going to get 8 equals 15x. We're going to divide by 15, so x equals 8 fifteenths.
Yeah, my eyes kept jumping between the questions, so I put equals 1 instead of equals 2.
Okay, so you were grabbing the 1 from 3.
Yeah.
Okay. So 8 fifteenths is our answer there. But the more that you understand the process of what's going on, the quicker you can kind of jump. But you should have your notes from question number 1 where we expanded everything out. Go back to that, kind of follow it step by step. Okay, again, I apologize if I've gone too quickly through that section. If I need to, I'll go back. All right. 5 and 6 are these color of the White House questions, and they're really, really easy, but I'm going to explain to you that you actually learned this back in Algebra 2, all right? So in Algebra 2, we talked about, if I had 2 log base 2, in this case, it's radical 7, okay? And I think I can even actually pull up the notes from that class, because we just covered this in that class. If it'll let me kind of move back to that. All right, and that's this right here, where if I have b with an exponent of log that has the same base as the number I'm working with, then the number of that log is the solution. All right, because if you look we go down here, if we have log, or 2 log base, the log base 2p, my answer is going to be p. Now, our question here does take that and complicate it a little bit more, because it says log, or 2 to the log base 2 radical 7 plus log base 2 radical, what, 10? Radical 10. I know it's really hard to read. It is early out. All right, so we'll finish this tomorrow, but suffice it to say your answer is going to be radical 7 times radical 10, so you should get radical 70 for an answer. All right, we'll finish this up tomorrow.
So tomorrow going to be a work day?
I'm going to finish the lesson tomorrow.